हेलो गाइस, वेलकम टू दिस वीडियो। इस वीडियो में हम डिस्कस करेंगे कॉन्सेप्ट्स के बारे में। ठीक है, इंपॉर्टेंट कॉन्सेप्ट्स क्या क्या हैं उसके बारे में। फर्स्ट शुरू करते हैं, स्केलर एंड वेक्टर क्वांटिटीज। व्हाट आर एग्जैक्टली स्केलर एंड वेक्टर क्वांटिटीज? यू हैव हर्ड इट, ऑब्वियसली यू हैव हर्ड इट, that what are scalar quantities and what are vector quantities. Okay, suppose you are going in a direction, in a certain direction. You have traveled from Delhi to Mumbai in a certain direction without changing your direction, then that would be told that will be considered as a vector quantity. If you have moved from Delhi to Mumbai in a by changing your directions, then that would be considered as a scalar quantity. Okay, scalar quantities. What are those scalar quantities? These are physical quantities which are expressed only by their magnitude. Okay, the thing that are only considered by magnitude only, that are said to be scalar quantities. Okay, uh, distance, there are some examples. Okay, first we need the following two parameters: unit in which the quantity is being measured and the numerical value of the quantity. What is the unit of the quantity? If you are traveling in means distance, then you have means you are traveling somewhere, then and you have to go from Delhi to Mumbai, you have to consider that how much kilometer, so unit is kilometer. Okay, got it. But and what is the numerical value? Suppose the distance is, let's consider that the distance would be around 1400 kilometers. Okay, so that 1400 is the numerical value of the quantity and the kilometer is the unit. So in if we tell that the distance is 1400 kilometers, then we are telling that it is a scalar quantity. Okay, or scalars, simply scalars. What are the examples? Mass, length, time. Okay, what is that? Mass, length, time, distance, density, volume, speed, temperature, potential, whether it may be gravitational potential, magnetic potential, or electric potential. Okay, that will learn further. Then what is work, energy, power, pressure, quantity of heat, specific heat, charge, electric power, resistance, density, mechanical advantage, frequency, angle, etc. These are scalar quantities. These doesn't need to be described in the directions. They can only be described in terms of their magnitude only. Okay. If you want to weigh something, you will not say that give me 50 kg of tomatoes in north direction. You will only say give me 50 kg of tomatoes. Okay, or you give me 5 kg of tomatoes, but you will not say in the if you give me 5 kg of tomatoes in north direction, in south direction. What does that mean? That doesn't make any sense. Okay, इसलिए हम जो कि ओनली मैग्नीट्यूड में डिस्क्राइब करते हैं उसको हम स्केलर क्वांटिटीज बोलते हैं। ठीक है, स्केलर क्वांटिटीज क्या हो सकते हैं? वो भी ऐड हो सकते हैं, सब्ट्रैक्ट हो सकते हैं, मल्टीप्लाइड हो सकते हैं, डिवाइड हो सकते हैं, वो भी सिंपल अरिथमेटिक मेथड से सिंपली हम उसको एडिंग कर सकते हैं। अगर आपको मीन्स 10 kg टमाटो के साथ 5 kg पोटैटोज ऐड करने हैं, तो फिर आप कंबाइनली अगर आपको एक सैक में लेके जाना है तो फिर एक सैक का वजन कितना होगा? सैक का वेट कितना होगा? 15 kg होगा। सॉरी, सैक का मास कितना होगा? 15 kg होगा। इसलिए हम उसको बोल सकते हैं वो कैन बी एडेड हो सकते हैं, सब्ट्रैक्टेड हो सकते हैं, मल्टीप्लाइड हो सकते हैं, डिवाइड हो सकते हैं। उसमें मीन्स क्या है, 10 kg का टमाटो है, 5 kg का पोटैटो है, बट स्टिल हम उसको अगर कंबाइन कर लेंगे तो फिर हमको उसको 15 kg बोल सकते हैं। फिर क्या है, मीन्स सिंपली स्केलर क्वांटिटी इज सिंबॉलिकल रिटन बाय इट्स इंग्लिश लेटर. Okay, we will write it symbolically in English letter. For example, mass is represented by small m, time is by small t, and speed is by v. Okay. Then we should come to vector quantities. What are vector quantities? These physical quantities require the magnitude as well as direction to express them. If you want to express them, then only their meaning is complete. Okay. If you are attaching a scalar quantity with direction, okay, scalar quantity is what? The thing that we can describe by magnitude. So this is only simply that by scalar quantities with direction. Then we can call it a vector quantity. Okay. If you are going to some place that is 50 kilometer from your home and that is in the north direction, so you will say that when I travel 50 kilometer north, I'll reach that place. Then that is considered as velocity. Means so that is considered as vector quantity. I beg your pardon. That is considered as the vector quantities. Okay, or simply vectors. For example, if you can displace a particle from a point by 5 meter, the first question will arise: what in which direction? Obviously, by saying that displacement is 5 meter, its meaning is incomplete. If you tell that the displacement is 5 meter, then the meaning will not be complete. But if we say that if you displace the particle from that point 5 meter towards east or 5 meter towards north, then we can say it has a complete meaning. Okay, we require 3 meters to express the vector quantity. First is a unit, and second is the numerical value, third is the direction. In the scalar quantities, we only saw unit and numerical value. As I told you earlier also that what a vector quantity is nothing but a scalar quantity with a direction. So here the third point that we add is direction. Okay, what is the displacement? Examples are what? Displacement, the distance with direction. I am traveling 60 meter towards east, then that will be considered as displacement. I am traveling with a speed of 600 kilometer per second in east direction, then that will be considered as velocity. Acceleration is similarly momentum, force, moment of force or torque, impulse, weight, uh, mass. In the if you are traveling, means if you are sending 15 kg of mass in the east direction, that will be considered as weight. Okay, that will be not considered as mass. The 15 kg of mass in the east direction, that will be considered as weight. Temperature gradient, electric field, magnetic field, dipole moment, and etc. Okay. The numerical value of a vector quantity along with its unit gives us the magnitude of the quantity. Okay, it is always positive. The numerical value and the direction is always positive. The negative sign with a vector quantity implies that the reverse direction or opposite direction. Okay, means if you are going to east and if we go to means the exact opposite of that, then we will say we can consider it by using a negative direction, negative sign. Okay, vector quantities follow different algebra for the addition, subtraction, and multiplication. A vector quantity is generally written by its English letter. Okay, English letter only we can denote vector quantities. uh, okay, just a minute. We have, for writing vector quantities, we have to use one symbol, that will be an arrow. For example, if what we write speed is small v, but when you write velocity, we have to write small v and we have to give a direction arrow above it. So when you give that arrow, then that will be considered as a velocity. Previously, if there is no arrow, then we will consider it as scalar. When you give an arrow, that will indicate that it is going in a certain direction. So then we'll consider that as velocity. Okay. Obviously, the forces F and minus F are in opposite direction. If F is acting around along east, and minus F will be acting around west, acting along the direction west. So then thus the opposite sign is used. Got the idea of scalar and vector quantities? Are you sure? Okay. Next topic would be the rest and motion. Okay. Every object in the universe is in motion. Every day we see bodies moving around us. Example, birds flying, cars, buses moving, people walking, insects crawling, animals running, etc. Our earth also moves. If you are sitting and watching this video, you can consider yourself at rest, because you are on earth and earth is moving. Even though earth looks still, but still earth is moving, and it is moving at a very high speed. So thus we can consider anyone at rest. Everyone is moving, everyone is in motion. Okay, our earth also moves around the sun, so very thing on it is in state of motion. The sun and stars are moving around the center of galaxy. So sun is also not stable. Sun is also moving around the center of galaxy. And the galaxies too are not rest. Galaxies are also moving around a suppose a black hole. which is at the center of the galaxy. The galaxy are also moving around that. So nothing is stable, means nothing is in state of rest. Everything is in state of motion. Even though we feel that we are in state of rest, but we are not. So मीन्स वो आइडिया को, वो स्टेट ऑफ रेस्ट का आइडिया को अपने दिमाग से निकाल दो, हम सब स्टेट ऑफ मोशन में ही हैं, ठीक है. Although nothing is at state of rest, but we often say that a stone lying on the ground is at rest because the stone doesn't change. Yes, if you means if the stone is lying on the ground, we say that it is at state of rest because it is not changing its position with time. But as I said also that the earth is moving. So if earth is moving, how can that stone be at rest? The stone is also moving. With the earth, stone is also moving. But it is not changing the position with respect to time as far as we are concerned. Means we are saying that it is under that, but it is moving. It is not in state of rest. Similarly, if we are sitting on a railway platform, we look at the tree, we say that the tree is rest because it does not change its position with respect to us. Okay, means if we are sitting in a railway platform and we are seeing the trees and all that are still, that are not moving. But when you are on the train and the train is moving, you could see that that means what the trees and all, they will be moving backwards. If you are going towards east, then they will be moving towards west. So how the perspective depends on on what you are. If you are sitting, you can see that it is at rest. But when you are traveling in a train, it will appear to you that they are moving in a backward direction. Okay, it is only depends upon the respect in the with respect to you are considering it. A body, memorize it. Okay, this will be an important. A body is said to be at rest if it does not change its position with respect to its immediate surroundings, while a body is said to be in motion if it changes its position with respect to its immediate surroundings. Okay, when the body does not change its position with the immediate surrounding, then we can consider it as rest. Similarly, when a body changes its position with respect to immediate surrounding, we'll consider it as state of motion. Okay, for a moving body, if the distance traveled in a certain time interval is much large as compared to the size of the body can be assumed to be a point particle. Okay, if the distance traveled in a certain time interval is much large as compared to the size, means if you are 6 foot guy with 80 odd kgs mass, and you are moving at a speed of 600 kilometer per hour, then the speed is very huge as compared to your size. So then you will be considered to be a point particle. In this chapter, we will study the description of motion of a body assuming it to be a point particle. Okay, just a second. Okay, one-dimensional motion. When a body moves along a straight line path, its motion is said to be one-dimensional motion. Okay, means if you are going to a certain position that is 10 meters ahead of you and it is in one direction, in the direction of the east only, then that would be considered as straight line path, and that motion is considered will be considered as one-dimensional motion. Okay, it is also considered as a motion in a straight line or a rectilinear motion. Okay, straight line or a rectilinear motion. Rectilinear means in a one direction you are traveling. Okay, for example, the motion of a train on a straight track, a stone falling vertically, a stone falling down vertically, a car moving on a long and straight road, etc., are one-dimensional motions. Okay, in such a motion, there is no movement of the particle in a lateral direction. There is no sideways motion. There is only one direction they follow. If a body moves on a plane along a curved path, its motion is two-dimensional, and if it moves in space, its motion is three-dimensional. If you can see that a aeroplane flying, that would be in three-dimensional. If you see that uh, in a curved path, in the racing, in the motor racing or in the car racing or in the bike racing F1, you can see that they will be moving in a curved path. There means the one one part of the whole race whole racetrack would be a curved path. In that case, that would be in the two dimension. Okay. How can you represent a one-dimensional motion? The path of a one-dimensional motion can be represented by a straight line parallel to the x-axis if x-axis is taken in the direction of motion. If y-axis would have been taken, then that would have been parallel to the y-axis. In case of a rocket, I guess you can also a certain direction in certain part of the direction of the rocket from the traveling of the rocket from the Earth's surface, you can consider it as a one-dimensional motion. Okay, this is how you will represent a direction in a one dimension. X is 0, x is 80 meters. Time at x, when x is equal to 0, the time is 0. When the x is at 5 meter, the time is 1 second. When the x is at 20 meter, the time is 2 seconds. And when x reaches the destination at 80 meter, the time is 4 seconds. Okay. The position of a pebble measured from its starting point, falling freely and vertically downwards at different distances is given below. Okay. When a position of pebble measured from its starting point, falling freely and vertically downwards. Okay. Then we'll consider, then this type of motion is seen. Okay. Then we have to come to the part of the distance and the displacement. Okay. If you are going, first listen, if you are going from Delhi to Mumbai, okay, let's consider that example only. And that is around 1400 kilometers. And but you have a relative in Ahmedabad, then you have to also visit her. So if then you go from Delhi to Ahmedabad to Mumbai. Okay. In both the cases, you have reached your destination. That means you're the starting point and the final point is same. Starting point is Delhi and the final point is Mumbai. Okay. Uh, which one would be means what? Which one would take less time as well as less distance? Answer it. It's a no-brainer, no? What the distance means the displacement, the smallest distance would be from Delhi to Mumbai direct. Delhi to Ahmedabad or on to Mumbai would take more time as well as the distance would be more. So displacement is nothing but the smallest distance. Okay, the smallest distance is considered as displacement, and that will be in a certain direction also. But let us consider that would be in a direction from a northwest direction. No, sorry, southeast direction from Delhi. But if we consider going through Ahmedabad, then that would be towards south. What that would be? Towards west. Then from west you will go towards southeast. So direction would be changed. But in case of displacement, the direction remains same. That is towards southwest from Delhi to Mumbai. So distance is what? You can see the example also in that A to B is the direct, and A here is moving here and here is going this way. Okay. Distance is what? The total length of the path through which a body moves. It is called the distance traveled by it. Okay. The distance traveled by a body depends on the path followed. It is scalar quantity. It is generally represented by letter S. The SI unit is meter and CGS is centimeter. The total length of the path covered, the total distance covered, total path covered, total length, that will be considered as distance. What is the displacement? The shortest distance from the initial to the final point is the magnitude of a displacement in a direction is from the initial to the final position. Okay, so consider it as a right angle triangle. It may doesn't look like, but consider it. Okay. So if you are moving from A to B, there are two directions. One is this, the direct, one is this. So if we move from this A to B, that would be C. If this is what 3 kilometers and this is 4 kilometers and this is 5 kilometers. 3 square say 9 plus 16 25. Okay. So what is that? We can by if it is a right angle triangle, then the hypotenuse plus perpendicular square, sorry, base plus perpendicular square root over is equal to hypotenuse. So if this is 3 kilometer and this is 4 kilometer, then total distance would be 7 kilometer, but the displacement would be the shortest distance. If you are reaching from A to C, that would be 5 kilometer. So this is the displacement and this is the distance. Okay, got it? The shortest distance from the initial to the final position of the body is the magnitude of the displacement, and its direction is from the initial position to the final position. It is a vector quantity and it is represented by capital S. Okay, have you got the idea of distance and displacement? If you have not, then please tell me in the comment section. Okay. Representation of displacement. The displacement, being a vector, is represented by a straight line with an arrow. Okay. Using a convenient scale, the tip of the arrow on the straight line represents the direction of displacement, while the length of the straight line on proper scale represents its magnitude. The vector PQ represents 40 meter displacement in each direction, with scale 1 centimeter is equal to 10 meter. Here origin P is the initial position and the terminus Q is the final position of the body. Okay, P is the origin and Q is the final position. It is 40 meter displacement. It is towards east. Okay, you can see here east, so it is towards east, and it is represented by a arrow mark. Okay, which suggests that it is in a one direction. What is a distinction? Okay, the magnitude of displacement is either equal to or less than the distance. The displacement, in there are certain cases in which the distance and the displacement both are same. Okay, means distance or magnitude of distance or displacement magnitude of displacement may be equal to or less than distance. In most cases that is less than distance, but in some cases that can be considered as also equal. If a motion is along a fixed direction, the magnitude of displacement is equal to that of distance. Okay, means if you are traveling in a certain direction, and that is also your distance and that is your also displacement. But if a motion is along a curve or any zigzag path, the magnitude of displacement is always less than that of distance. Okay, magnitude of displacement can never be greater than distance. You have to memorize it. You have to get the idea that means what the magnitude of displacement can never ever be more than magnitude of distance. It can be equal to or less than. Okay. Another one is the distance is the, you can read the examples of, the distance is the length of the path traveled by the body, so it is always positive. Distance is always positive, but displacement is the shortest length in direction, so it can be positive or negative. Okay, displacement can be positive or negative, but distance is always positive. The displacement can never be zero, even if the distance can be zero. Displacement can be zero, but distance can never be zero. If a body is traveling, if a body of traveling comes back to its starting position, the displacement is zero. Means if you are traveling, you have traveled from your Delhi, you started from Delhi, you have reached Bhubaneswar, then you have went Mumbai, then went Ahmedabad, then went, then in that case, what will happen? The displacement would be zero. Okay, when a body is thrown, that will be all for today. Thank you for watching my video. Keep liking the videos, keep subscribing to my channel. Thank you. We'll meet. I will see you in the next one. Okay.